It's simple as that, right? The acid has a charge of positive. So you can oxygen as a charge of -1, and oxygen is hydrogen be the hydrogen side. So it can be this. So you have to remember this is -1. So it's E to plus and then OH negative. So then to be positive equal 0. So what you have to do is to crisscross this. Then you have 1 iron and you have 2 hydrogens. Now this is the part of that can do. So you want 1 iron, then you have hydrogen bonds there, but you also 1 with this. You have the oxygen, then hydrogen here, and oxygen, then hydrogen here. Now each of these hydrogen needs to have 8 electrons around it. So each of these bonds equals 2. So each bond equals 2, each bond equals 1. So you have 8. So you put 4 dots. And this is going to need 4 dots and 4 dots. But hydrogen only needs 2 because this is small.
What the biggest problem in space is?
It's your copy, and we don't know.
I'm sorry, it's actually space radiation. They can affect astronauts in disastrous ways.
We're the ISA, also known as ITExperts Space Administration. Look at that. This is Zeus 18, our spacecraft now going to Mars.
Now we're about to meet the astronauts that are going onto this mission.
Hi, I'm Astronaut Asteroid. Hey, I'm Astronaut Gravity. And I'm Astronaut Crater. We'll see you guys in the spacecraft.
Ready?
3, 2, 1, lift off!
Attention! We are passing through the ozone layer, which means we are passing the magnetic field. Stay alert for any updates.
Awesome, we'll be on the lookout.
Now we're passing through the stratosphere.
Attention! Your spacecraft is currently in the exosphere. Now we're located into deep space. Congratulations, astronauts.
Beep,
beep,
Attention,
beep,
all
beep,
space travelers! The
beep,
solar flares that
beep,
collided into your shuttle
beep,
are
beep,
incredibly disastrous!
What's happening?
We're about to lose connection!
Wait, what?
I repeat, we're about to lose connection.
Try to find the red button in the control panel. We might gain connection. Where's the red button?
But there is only one button!
You know what? Mission control. Are you there? I repeat, are you there?
Hello? Hello? As you can see, radiation is a major problem in space.
It can affect parts of the body and the brain. Of course, all of this was an exaggeration of what types of radiation can do. Real life, the effects will take much longer. Out of 9 Apollo missions, 33% of the astronauts have died due to radiation. There are many different types of radiation, such as gamma, beta, solar flares, galactic cosmic rays, and much beyond those.
Our protection from radiation isn't that effective if you're staying in space for a longer period of time. Wait, then how is Earth radiation different from space radiation?
Well, the Earth's atmosphere has a magnetic field that surrounds us and helps protect us from storms that go right through our planet.
The Earth also has 2 radiation belts on either side of the Earth that traps protons and electrons that come from the sun.
Astronauts can receive 10 times as much as radiation as there is on Earth. They can also receive 50 to 1,000 millisieverts in a 6-month trip.
Wait, what happens if we don't have the right protection?
Well, good question. Radiation can affect you in major ways. You also have a high risk of getting cancer.
You guys could even get sick and have behavioral changes. Some astronauts could get anorexia, which is a food disorder if they're exposed to types of space radiation.
That's not good.
Well, what do we do now?
I heard that you can use water to shield radiation. Plus, that's something that we already have.
That could work, but you would need Olympic pools worth of water, which would be way too heavy to bring to space. Plus, that wouldn't help the world's water problem either.
Wait, but I heard lead was better than water. Yes, it might be, but it make the spacesuits extremely heavy, which would weigh down the astronauts and the rocket, and that would require more fuel too. Hey, Prina, didn't you research about boron nitrogen nanotubes?
Yes, I did. But NASA's currently developing boron nitrogen nanotubes, so it'd not be innovative of us if we had to use their solution. Plus, they're very expensive.
Presenting RadiShield.
It's made out of iron 2 hydroxide and fused silica.
Iron 2 hydroxide and fused silica are both non-flammable.
They both also have a very low density, therefore our solution would be light, but also very effective.
Infused silica can protect astronauts from short radiation wavelengths. Plus, they're very common and very inexpensive.
Our solution is on the capsule. It has many different layers. Think of it as a sandwich. The 2 slices of bread are the fused silica fibers, and the filling inside is the iron 2 hydroxide. Normally, the radiation will go through here. When you put the RadiShield on, it will bounce right back off. Our solution has 3 layers, which means that if one layer should be attacked by a galactic cosmic ray or a solar flare, there would be 2 more layers left to support it.
Fused silica can withstand high temperatures up to 1,260 degrees Fahrenheit. Because of that, the capsule is protected fully from re-entry. After we designed your solution, we reached out to experts to show and validate our solution. We talked to Connor Morris, a NASA intern, Ken Walzak, who works in the Far Horizons Laboratory at Adler Planetarium, and Pooja Desai, a NASA engineer, and they were able to validate our solution.
We also presented to an audience at the Schomburg Library.
We also share our solution with many students and teachers since we at our schools.
We are also a part of Expert Education Foundation. We reached out to over 100 students to to converse about our problem and solution.
With our solution, we'll make an impact to curb space radiation problems that astronauts face.
We made sure our solution could double up as a heat shield because of our space hero, Kalpana Chawla.
She was the first Indian American woman in space and died on the return of her second mission.
At launch, a piece of insulation had broken off and damaged the heat protection system of the shuttle's wing. This was not supposed to happen, so therefore our solution would help prevent that.
Thank you for listening.
Okay, thank you.
For the project award, the judges look for teams whose quality research, innovative solutions, community sharing, and presentation best reflect an in-depth understanding of the scientific disciplines involved with the project. In order to be eligible to win this award, each team was required to identify a physical or social problem faced by humans during long-duration space exploration within our sun's solar system and propose a solution. The judges had this to say about the winning team. The team who talked about radiation and how it impacts the space program. The team with blue t-shirts and astro suits outfits. The team who talked about a spaceship accident, Kalpana Chawla. I may have totally butchered that name and I apologize. We don't have a winner here. It's IT expert.
Good job.
All right, the next one is our Core Values Award. First Legal League presents